Hello, architects. When we talk about building production systems for banking and fintech, we aren't just talking about code. We're talking about architectural gravity, the weight of your data, and the precision of your retrieval. In this environment, your retrieval strategy is the single most important component of your AI stack. If your model retrieves the wrong data, it hallucinates with the authority of your bank's reputation. One wrong answer on a regulatory query can trigger a compliance audit. Today, we're doing a deep dive into the evolution of RAG, from naive to advanced to graph RAG. We'll look at why each matters, where they break under pressure, and how to build a pipeline that survives production. Let's start with naive RAG. It's the hello world of AI. Document to chunks, chunks to vectors, cosine, similarity search, and generate. It's the standard implementation for a weekend prototype or a simple internal FAQ bot. But when you drop naive RAG into an enterprise environment, like a bank's internal compliance department, it starts to crumble. When your knowledge base is 100,000 pages of dense regulatory text, simple becomes unreliable. Naive RAG uses fixed-size chunking. If a critical interest rate policy is split across two chunks, the semantic search might only find half the story. In banking, half a story isn't just a wrong answer, it's a legal liability. Then there's the noise. In financial services, many terms are semantically similar but legally distinct. Naive embeddings often confuse Regulation E with Regulation Z because they share the same context, leading to confident but incorrect responses. This leads to the precision recall trap. Your system finds 10 documents that look right based on keyword density, but none of them contain the specific exception the customer is asking about. This is high recall but low precision, the architect's nightmare. To fix this, we move to advanced RAG. This isn't just about better prompts, it's about a fundamental rethink of how we represent and retrieve our data. We need to bridge the gap between search and understanding. One of the most powerful tools in advanced RAG is parent-child chunking. We separate the retrieval representation from the generation representation. We store small child chunks for high-precision vector search. Once we find a match on a child chunk, we feed the entire parent context, the full section or page, to the LLM. This ensures the model has the full picture, solving the context fragmentation issue of naive RAG. Think about a credit card agreement. A child chunk might find the specific line about late fees, but the parent context explains that these fees only apply to accounts in good standing. Without the parent, the model misses the good standing exception. Advanced RAG can also be used for real-time transaction enrichment. By retrieving context from merchant databases and past user behavior, your assistant can explain why a specific fee was charged in plain language. Advanced RAG also uses hybrid search. We combine the semantic power of vector search with the literal accuracy of traditional keyword search, like BM25. This is essential for finding technical terms. In finance, you often need to find a specific transaction ID or a Swift code. Vector embeddings can be too fuzzy for that. Hybrid search ensures that if the exact ID exists in your docs, we find it with 100% certainty. But the real secret sauce of advanced RAG is reranking. Vector search gives us a candidate list of the top 50 results. Then, we use a more powerful model to re-rank them for true relevance before generation. This cross-encoder re-ranker looks at the query and the document together, catching nuances that a standard vector search misses. It acts as a final quality filter, ensuring only the most relevant context reaches your LLM. For developers using the Stripe API or UPI protocols, reranking ensures that the RAG system retrieves the exact integration spec for the error code you're troubleshooting, not just general documentation on payment flows. Another advanced technique is query expansion. We use an LLM to rewrite the user's question into multiple variations. This helps find relevant chunks even when the user uses different terminology than the documentation. We can also implement a self-correction loop. The system checks if the retrieved context is actually relevant to the question. If not, it triggers a new search with a different strategy. This is agentic RAG in action. For legacy core banking systems, RAG acts as a bridge. It can index 30 years of system documentation, allowing new developers to query complex COBOL logic using natural language, significantly reducing technical debt. However, even advanced RAG treats documents as isolated islands. It can't reason across relationships between different entities. To bridge this knowledge gap in complex domains, we need GraphRAG. GraphRAG starts by transforming your unstructured text into a knowledge graph. It identifies entities like customers, businesses, and accounts, and the relationships between them. It turns a text into a map of meaning. Unlike standard RAG, which retrieves pieces of text, GraphRAG can perform global reasoning. It can answer questions like, what are the main risks across our entire commercial loan portfolio, by traversing the entire graph. In cross-border payments, GraphRAG can reason through complex correspondent banking networks. It understands which routes are fastest or cheapest by connecting disparate bank-to-bank relationship data into a single graph. Think about fraud detection in a neobank. GraphRAG can see that 3 disparate accounts are all connected to the same burner phone number mentioned in different KYC files. Standard RAG would never make that connection across documents. Vector search finds similarities in language. Graph search finds connections in logic. In complex financial systems, the hidden connection between entities is often more important than the similarity of the text describing them. Monk. GraphRAG also handles entity resolution. It knows that J. Smith and Jonathan Smith are the same person across different systems, preventing the data fragmentation that plague naive RAG implementations. Mang. As an architect, you must measure your success. We use frameworks like RAGAS to score faithfulness and relevance. In banking, you can't go to production without a verifiable accuracy score. Mang, security is paramount. Before data even hits your vector database, you must implement PII masking. Your RAG pipeline must be designed to handle sensitive data without leaking it into the LLM's prompts. Mang. Furthermore, your retrieval must respect access controls. If a user doesn't have permission to see a specific loan file, your RAG system shouldn't retrieve it for their query. This is authorized retrieval. Mangi, RAG, is transforming regulatory reporting. Instead of manual data gathering, an advanced RAG system can pull the necessary figures and qualitative explanations from across the bank's internal documentation to draft call reports. Mang. So, how do you choose? It depends on the architectural gravity of your use case. Start with naive for internal FAQs, but move up the stack to advanced or graph for anything mission critical or complex. Mang. Remember the trade-offs. Advanced RAG adds cost and latency. GraphRAG adds significant indexing complexity and compute requirements. Don't over-engineer if your data is simple, but don't underbuild if your precision requirements are high. Mang. RAG is even helping with cloud migration. By indexing legacy code bases and architectural diagrams, it can suggest target microservice boundaries, making the move from on-prem to cloud much more predictable for banks. Mang, when building for enterprise scale, ensure your vector database and graph store are managed services. Reliability is just as important as retrieval accuracy in production banking systems that serve millions. Finally, plan for maintenance. Regulations change. Your knowledge base must be updated constantly. A production RAG system needs a pipeline for automated re-indexing as your underlying data drifts. Mangi, your mobile banking assistant, is the face of your RAG implementation. By connecting to real-time account data and internal policies, it can provide personalized, accurate answers that build trust with your customers. Mang, looking ahead, the next frontier is agentic RAG, where the system doesn't just retrieve, but acts on the data. It will cross-check its own answers against multiple sources before ever presenting them to a human. Manka, I want to hear from you. Are you sticking with advanced RAG, or are you experimenting with knowledge graphs? Drop your thoughts in the comments below. Let's build better, safer systems together. Thanks for watching this deep dive. Subscribe for more software architecture content focused on the financial sector, and I'll see you in the next one. Keep building and stay precise. Mangs.